one. It was from test 3. It
Okay.
was, let me find it. It's the one with the hot air balloon and observers on the hill. It's question number 11.
Okay, test 3. I'll put
Mhm.
that down for people who, when they go back, want to kind of find it. And it was, you said number 11. Test 3. Gotcha. I guess I could use your numbers, that way it's easier for you to match it up, because they do change the numbers for almost everybody. It's random. Okay. Almost there. Yeah. 11 coming up. Oh God, yes, I remember this one. So let me draw. There's a picture associated with this, and it's quite a messy picture. But essentially, you've got a hill that looks something like that, and you've got a horizontal dotted line, and you've got a point P, which I'll put here, and another point here, we'll call it Q, and there's a balloon up here, which I guess I'm going to call R. So I'm going to do P to Q there. There is no reason in the world that that's the right angle, right? It's just an angle, it's just a drawing. And what else do we know? Observers at P and Q are located on the side of a hill that is inclined at 32 degrees. The observer at P determines the angle of elevation to be 62 degrees. So you've got to kind of figure out what's going on here. This angle of the hill, just from here to here, that is a fixed 32 degrees. They then went on and said that the angle of elevation, now the angle of elevation is this angle. And they told us that this angle was 62, which makes this angle in here 30. Because if that whole thing is 62 degrees and this bit is 30, do you understand where that angle 30 is coming from now? So far, so good. Okay, now what we want to do is we want to go and read on a bit further. At the same instance, the observer at Q measures the angle of elevation to be 71 degrees. And darn it, I wish my picture had been better. So let me try and doctor it so that it makes more realistic, right? So you pretend this is R, right? So there's the guy. That's not there anymore, right? And the angle of elevation they're talking about, if you add in another dotted line, is this angle here. And they said that this angle here was 71 degrees. But this slope of the hill is still 32. So if you take 71 and subtract 32 from it, you get 39 degrees. So this picture is already getting pretty messy, but every little bit helps.
I don't really understand that last step with the
This 30-degree thing?
Yeah.
Okay, let's take all the pictures out of the way. Angles of elevation are measured from horizontal. So if someone says the angle of elevation is 62 degrees, they mean that this angle here is 62 degrees. Are we comfortable about what they mean by angle of elevation?
Yeah.
Right. Now, if I put on that there's a hill going like this, that angle there is still 62 degrees, right? That's not changed. But there's a hill. And this hill makes an angle from here to here of 32 degrees. So can you imagine, you know, the whole thing, and you know this piece. Does it make sense then that this little angle here is 30? And how do you get it? 62 take away 32 leaves me with 30. So on this picture that I've got here, I'm only going to put in the slope of the hill and the slope to the balloon, right? The balloon's up here at R. And that angle we just found was 30 degrees. Okay. Now, if you do this angle of elevation here with all the other lines going on, this is essentially the hill, right? If you do the little dotted line, this is the slope of the hill, so that's still 32 degrees. But the angle of elevation to the balloon, that's this angle. And they told me it was 71 degrees. And that tells me then that this piece here, which is the thing I'm looking for, is the other 39. So if I draw this guy to here, and then I just continue the hill, I found out that this angle here is 39 degrees. With less things in the way, can you see where I'm getting these angles from? They're the angles from the slope of the hill to the line, not from horizontal to the line, but the slope of the line to the other line. Mm-hmm. Now, somewhere in here, they tell me if P is 60 meters from Q. So they've just told me that, put in my letters, there's P and there's Q. They've just told me that this distance here is 60 meters. Now, I'm almost done, except I need to know this angle. Is there any way I can find the size of this angle at Q based on what you can see in front of you? I know this is a straight line.
Yeah, it's 180 minus 39.
So that's 141 degrees. You all comfortable about where that 141 came from? Now that I've got that, I realize I can do even better. Because if you add 30 and 141 together, you get 171 degrees. Doesn't that make this little guy up here 9 degrees? So what I've really got is a triangle where I know quite a lot of sides, quite a lot of angles, and one of the sides. So the triangle that we're talking about is basically this one. And this is 141 degrees. This is 30 degrees, and this is 9 degrees. And I know that this distance here is 60. So what am I being asked to find? Find the distance from Q to the balloon. Q to the balloon. So they basically asked me to find QR. So a lot of the hard work was to create this triangle. Right, let's look at this triangle where all the sides, all the angles are known and one of the sides is known. Sine rule or cosine rule? Well, if this is angle P, that'll be little p, and this is little r, and this is little q, then I can do sine P over little p, sine Q over little q, and sine R over little r. And I know all the angles, and I know little r, and I'm trying to find QR, which is little p. So that tells me that these two with the balloons around them are the version of the sine rule I'm going to use. So it's going to be sine P over the side little p, sine of R over little r. And that's going to be the sine of 30 degrees over, we don't know, equals the sine of 9 degrees divided by 60. Okay, mathematically, what should my next line of working look like?
Cross multiply.
Okay, so if I do P times the sine of 9 degrees, it should be 60 times the sine of 30 degrees. And then to find little p, shouldn't I divide both sides by the sine of 9 degrees? And then calculus. I'm going to deliberately do a mistake here. Okay, it's 60 times sine of 30. This is a deliberate mistake. divided by the sine of 9. And there's the answer. Would you agree negative 143 feet sounds wrong? Has anybody any idea what I did wrong?
You didn't isolate the bottom or like put parentheses?
Got another parenthesis. Sometimes that's the cause, not this time, but yeah, sometimes you need a bracket that you didn't. And that's true, but in this case, that wasn't the issue. The fact that you can't think of it is a good example of why this one is such a common one. Last chance before I tell you. My dog down here she's wanting attention. I was in radians, not degrees. I mean, it's so easy to do, isn't it? Because whatever the last thing you're doing. Now, if I go back to that question and change it to degrees, I should just be able to bring up the entry again. And there's the answer. And doesn't 191.7 or 0.8 rounded off, doesn't that just make more sense? Now, I can imagine this happening in an exam, and would you agree that we've done everything right, but you hit that number, and then you say to yourself, I've screwed up somewhere, and don't you go in and start changing things that should never be changed, instead of just noticing the angle. If you can't see anything wrong, all you will do in the exam is you will write down negative 143.8 meters, right? And move on. But it's wrong. Yeah, you're right, it is wrong. But isn't 90%, well, maybe 95% of what I've done, isn't it exactly correct? Isn't the only thing wrong button on my calculator? In the big scheme of things, that's not a really bad mistake. Isn't that something you catch 9 times out of 10, but in an exam you forget things, right? So I would say, okay, you're not getting 20 points. I'll give you 18. What would be the worst thing to do is actually undo this and doing some cosine rule that it was never designed for, or start changing angles by adding them because subtracting them never worked, right? So you just start doing random things because you can't think of, a good thing to do. Bad idea, right? If you're comfortable with the process, trust the math. If something goes wrong, oh God, how many times have I made a mistake? Do you know sometimes you type in 6 because you just didn't pay attention and the answer comes out weird, right? Since I'm going to be seeing all your working, I can check that. That's an easy thing for me to do. So, you don't want to waste time like spending another 20 minutes doing it. That's just bad usage of your time. So if you think the method is right, spend a few moments just seeing if there's something obvious that you may have missed. But if that ain't happening, leave it alone and move on. Better usage of your time. You can always come back to it at the end if you've got 20 minutes left. Right, next question.
I have one from the last test we took, actually.
10?
Yeah.
Okay.
It was the very last one for me.
Okay, let me find that one. And there we go. Question 10 from test 10. Okay. Okay, so it's a package. Well, probably should write it down there. Package that weighs 400 pounds. Is placed on an inclined plane, right? Inclined plane. And a force of 90 pounds is sufficient to keep it from sliding. So force of 90 pounds to not slide, just abbreviating that. Find the angle of inclination, find theta. Right, let's put the package here. Right, that's 400. Right. Gravity is pushing down on it. Great. So when I look at this question, I'm basically saying, okay, if it's not going to slide, it must be balanced in some way. This is the y component. The formula for the y component is basically the magnitude of the force times the sine or the cosine of theta. Which one gets you the y component of a vector?
The sine.
The sine. So we've got that. Now we know that the y component is put them the right way around, is 90, and that the force of gravity is 400. And so 90 divided by 400 is the sine of theta. And so I just need to do an inverse sine. Am I in degrees? I am. And so inverse sine of 90 divided by 400. And the answer I get is about 13 degrees. And that's the right answer. So I was just interpreting what the force that you need to compensate for gravity is, right? We're trying to balance the forces essentially.
So there's a 90 pounds of force pulling up on the package too to keep it from sliding. Is that where that comes from? Or?
I believe. Yeah, I guess so. Yes, the angle is, I'm not seeing it that way because I'm not an engineer, but I do know what the calculation is. There's a 90 pounds of force pushing down. And the reason why it's not the whole thing is because it's an angle, right? If you had 400 pounds on a horizontal, wouldn't the force of gravity be 400? But when you put something at an angle, isn't the force of gravity dependent on what that angle is? If you take a box and you put it on a really steep hill, isn't there a big tendency for it to slide down that hill? And if it's in a very shallow hill, isn't there a very small tendency, right? In other words, a big force would be needed to stop something from sliding down a steep hill, but a very small force would be needed by a flat one. You see, it depends on that angle, because that angle could be steep, big force, shallow, little force. In this case, it's a 90 pound that you're fighting. So what angle would you need for a 90 pound force? Right? I mean, if I change that 90 to 400, you'd end up that the angle was 0, right? If I change that to 90 to 200, I think the angle would be 60 degrees, if I'm right. I think it's 60.
And how did you know that you were looking for the Y component?
Just the story, it talked about the force of gravity and something on a plane. So I know, I can't say. I mean, if I ever see a question involving something not sliding down a plane, I know it's gravity that you're fighting. So it's just, that's not a good answer, is it? I know is much of a good answer. How about this? Now that you know it, the next time you see a box not sliding down a hill, won't you know it's gravity as well? Because I bet you that's how I found out, right? I got a question once and I can't remember it, but I'm sure I did. I got a question once and I said, I wonder what's happening. And I was told, it's gravity and it's a hill and this is what you do. And then it sticks in your head. So
gravity is always the Y component?
Y is the gravity, yes.
Okay.
Because gravity is a vertical force, right? So that I can I think most people would agree, right? Gravity is vertical force, right? It's pushing you down towards the earth, right? Are we good? But you want a joke before we do the next one? Okay. I've got a couple of jokes. This was told to me, two that were told to me by different students today. My ex-wife still misses me, but her aim is getting better. No, don't have an ex-wife, right? Why if a person, let's phrase this again. Why does a person who's walking along a road, why can't they blame someone? It's their own asphalt.
Why did the skeptic fail trigonometry?
Oh, a math one. I don't know why.
He couldn't see the signs.
Oh, yeah. Okay. Right, I think I'm ready for the next question. Neither of you are not. What you got for me? Chloe, come
I
here.
actually have a question, if it's okay.
Yeah, hold on a second. Come here. My dog is doing something she shouldn't be, and I don't want her to kill herself. Come here. I got you. Ah. Right. Just take her for a second. This young lady was trying to chew the cable on the lamp, which is not really a good idea. Yes, you. Yeah, you kiss me now, but a minute ago you were chewing on cable. So what do you know? There, right. Okay. No chews. Right, sorry about that. Right, you are ready for a question. Is it Paris?
Yeah.
Okay.
Honestly, for me, it's the first 3 questions in test 6.
Okay, let's go for them. Test 6, first 3 coming up. And these are find the exact values. Okay. So you've got the sine of 44 degrees multiplied by the cosine of 16 degrees plus the cosine of 44 degrees and times the sine of 16 degrees. Now, the minute they say exact value, forget about using a calculator. It's not going to work. Right? All the calculator is going to do is tell you the answer's, nothing 0.1234, and that's not an exact value. What you have to look at is that this is in fact one of those add subtract formulas. You remember the ones for the sine A plus B and the cosine A plus B, things like that, right? So if you call this A and you call 16 B, it looks a bit like that. Does anybody recognize which one of the sine or cosines of A plus B or A minus B this one is? And you should have a little card with all these guys on it, but does anybody just know it off the top of their head?
Isn't that sine A plus B?
It is. Now that you recognize that this is that, it now becomes what's the sine of 44 plus 16, which now becomes the sine of 60. And would you agree the sine of 60 you can get from your unit circle as an exact value? Has anyone got their unit circle handy? Because I don't have mine. Although I could probably make one if I had to. Here we are. Good. If you want to find a sine of 60, aren't you looking for a y coordinate, right, of 60 degrees? 60 degrees, y coordinate, √3/2. Okay, that's that one done. Now, that's just part 1A. 1B is different again. we are trying to find the exact value of sine 75. This time, you have to realize that you can break it into two guys added or two guys subtracted, whatever it is, two angles. And if I call this guy A and I call this guy B, don't I basically use this formula again, but in a different way? So what do I get? I get the sine of A cosine of B plus cosine of A the sine of A. And that becomes the sine of 45 degrees times the cosine of 30 plus the cosine of 45 degrees times the sine of 30 degrees. And then the unit circle takes over. Right, you want the sine of 45, you get root 2 over 2. Cosine of 30 is root 3 over 2. Plus cosine of 45 is root 2 over 2 times the sine of 30, which is a half. And those two get you root 6, and that guy gets you root 2, and 2 times 2 gets you 4, and that's your answer to that one. So these are applications of the sine, cosine of A plus B or A minus B. Do you want to see the third one, or can we move on to question 2? Alice, what do you want?
Well, honestly, the third one was the one I was the most confused on.
Okay, let's do that.
That's okay.
No problem.
Thank you.
We're wanting to find, again, it's all to do with sine, so I know it's one of these guys here, right? I just need to know how to split it. So it has to come from one of these angles here, and we have to add or subtract to get 11/12. Okay, now what might be a problem here is that the numbers are easier, right? It's easy to add and subtract numbers. It's much more difficult to add and subtract fractions. So one way around this might be if I just imagine some of the answers and what they look like. Pi upon 6 can be thought of as 2/12 pi, right? Pi upon 4 can be thought as 3/12 pi. And pi upon 3 can be thought as 4/12 pi. Right, now if you go up to here, you get pi upon 2, which is 6/12 pi, right? So far, so good? Now, one of these guys, well, sorry, two of these guys added, or two of these guys subtracted, should come to 11/12. So what you're looking for is two that add up to 11, or two of these guys, if you subtract them, you get 11, right? So for instance, if you went to this one here, wouldn't this one here be 8/12 pi? You see this one here? 8/12 pi. I'm going to use that one. I'm going to use 2/3 is 8/12. How much do I need to get to 11/12 then? I've got 8. I want 11. What do I need? Right, you need 3/12 pi. Isn't 3/12 pi just a quarter? Do you see that was just uglier, but it's still two guys that add up to get you 11/12 in this case. Right, it's just a bit harder to deal with. So if you get a question and it's multiples of 18, you can do a little baby unit circle, can't you? Just turn everybody into 18ths, right? It's 3/18ths and so on. Now, once you've got that, this is A and this is B. So your answer is going to be the sine of A, which is 2/3 pi, times the cosine of B, which is 1/4 pi, plus the cosine of A, which is 2/3 pi, times the sine of B, which is the sine of 1/4 pi. 2/3 sine root 3 upon 2. That guy, root 2 upon 2. Cosine of 2/3. 2/3 cosine -1/2 and √2 upon 2. That guy is √6. Take away a √2. 2 times 2 gets you 4. There is your answer.
Could you also, when trying to find what you add to get the 11/12 pi, could you turn that into degrees? Because that's how I've done it.
Oh, that is a good idea. Now, you want to turn that to 11/12. How many degrees is 11/12? Okay, how do you turn 11/12 into degrees?
Multiply it by 180, which is 165.
Okay, so you do 11 divided by 12, right? 11/12. And you may multiply it by 180 because the pi's cancelled. But got to be careful with brackets here. 11/12. Then you multiply that by 180, and there's your answer. It's 165 degrees. And you were saying, I agree with you. Isn't it just easier to work with numbers? So in your case, there might be more than one answer, but couldn't you go 120 degrees plus 45 degrees? And you'd get the exact same calculation. So that was a good strategy, Grace. That one works, but I like this one better. Okay, so you're saying number 2 now? Right.
Yeah.
Yeah, right. Number 2, this whole section was all to do with A's and B's and so on. In this case, you're being asked to find the cosine of alpha plus beta. And you're being given 2 triangles to get all the things that you need. This first triangle has an alpha and the sides are 2 and 3. And this second one is a 3 with a 6, and this angle here is called beta. And I already know what the cosine of alpha plus beta is. It's the cosine of alpha, cosine of beta, take away, I know that looks weird, but it's right, sine of alpha, sine of beta. And all of these sines and cosines are going to come from, if it's to do with alpha, from this triangle, and if it's to do with beta, it's going to come from this triangle. Of course, they didn't give me everything. I'm missing a side. Well, in this case, it's 9 and 4, so this is the square root of 13. And this side is 36, take away 9 is 20, let's not risk it. 36, take away 9 is 27. And all I do is use SOHCAHTOA, so here goes. If you want the cosine of alpha, it's 3 over root 13. If you want the cosine of beta, it's 27 over 6. Take away. You want the sine of alpha, it's 2 over root 13. And you want the sine of beta, it's 3 over 6. In this case, the bottom is that guy. And that guy is, what, 81, take away 6. So that's essentially 75 over 6 root 13. And you could probably leave it like that. What's she doing now? No! God, it's worse than having a baby. She wanted to go into the bin now and eat whatever she can find, which tends to be paper. I hope all that, me changing plan. Are you comfortable about where that one came from? Right. Identify the right formula. Add in the extra missing lines and then get SOHCAHTOA, get the pieces and make them pretty. And now the third one is simplify the tan of theta over a cosine theta minus a secant theta. If you got this question as an identity, wouldn't they tell you what it was equal to, so at least you knew what the answer was? These are a bit harder because you really don't know what it's going to simplify down to, except that you know that it can be made simpler. What is the first strategy you typically do in a question like this? It's the first thing you do.
Turn it to sines and cosines.
That's what I would do. So sine theta over cosine theta. Cosine theta. Right, does anybody know what a secant is? If you write it in terms of sines or cosines. What does a secant get you?
1 over cosine.
Correct. And you normally, it makes things that are uglier, which this certainly is, before it gets better. So would you agree I've got a really, really ugly fraction here? So a strategy that I use a lot is multiply the top and bottom by the same thing, right? Essentially a special version of 1. What should I multiply the top and bottom here by?
Cosine over
Cosine.
Agreed. So this fraction times a cosine kills the fraction, and now you only have sine. This times itself gets me cos squared theta, and this times this gets me minus 1. And now you're looking, and you know, everyone's kind of unique. Everyone's a little bit different from the one that came before. But what we're looking at here can be made better. Has anybody got any ideas how to rewrite cos squared theta minus 1? I'll give you a clue.
Sine squared theta.
Okay, would you agree that that is sine squared theta? So what do you think that is? It's not quite the right way around, is it? It's back to front. So if that is sine squared, what do you think that is?
Oh, is it a negative sine?
Yeah. It's a negative. So what we have here is sine theta over negative sine squared theta. Oh, that's cool. Can't we cancel a sine? And now we have got negative 1 over sine theta. And you would probably think you're done, but there is a rule in trig which says, if you can get rid of fractions, do it. So isn't 1 over sine theta also called cosecant theta? And that's the answer that they wanted, this one here. Are we cool with that one?
I don't like
Yes.
it, but yes.
Oh, I like it. I like sneaky ones. I think they're fun. Well, they're fun when you get them right. They're not so much fun if you can't figure them out or you get them wrong. Okay, that was a good variation in triggy stuff. Who's got the next question? Or what is the next question?
I have one that's kind of similar to these. It was, I think from 7.5, so it's solving trig equations, and it was the cosine of 7 theta minus the cosine of 9 theta.
Okay, 7 theta. What question number was that in 7.5?
Number 10, I think.
Whoa, always the end, isn't it? That's where the ugly ones live.
Mm-hmm.
Yeah, they tend to start off reasonably okay, and then by the time you get to the last couple, you're in trouble. Okay, so question 10, solve this equation by using the sum to product formula and enter your answer as common separated list. Right, so if you take the cosine of 5 theta and you subtract the cosine of 7 theta, and it's going to equal 0, and they're telling you to use a thing called, what's it called? Sum to product formula. You would have on one of your cheat cards all the sum to product formulas that there are. Right, now I'm going to call this guy A, right? And I'm going to call this guy B, right? And the formula that you get is negative 2, the sine, make sure it's a sine, yeah. It's the sine of A plus B halved times cosine it should be. I'm double checking here. No, I'm wrong. I'm glad I double checked. And it's the sine of A take away B over 2, right? So that's for a cosine A take away a cosine B, the formula is -2, sine of them added and halves difference in them. So it's now going to be -2 the sine, 5 theta plus 7 theta, and then you half it, times the sine of 5 theta take away 7 theta, all divided by 2, still equals 0. I can tidy it up a little bit more. That guy gets you 12, half of 12 gets you 6. That guy -2, half of -2 gets you -1. And you are now looking at that. So far, so good. Right, now, I'm glad that's 0, because if it was any other number, I'd be in trouble, right? Can I divide everybody by -2? You comfortable with that? I'm just trying to make it simpler, right? The -2 doesn't help, right? Get rid of it. Well, then, if two things multiply together are 0, then doesn't that make each one of them has to be 0, right? That's the only way that could happen. Either the first thing is 0 or the second piece is 0. Are we good? So, if you find when is a sine equal to 0, don't you get the answer 0? Great. What other angles give you a sine that's equal to 0?
I only thought there was pi.
If you wanted to, couldn't you then do 2 pi and, get bored, right? I'm going to use this one. If you divide this, don't you still get 0? If you divide this one, don't you get pi upon 6? And this is just overkill. You don't really need these. I'm just going through it. There is an infinite number of answers. So far, so good. Right. Let's just take this one. Isn't the formula 0 plus the period times k? Can you remember that rule? How to generate the infinite answers? What is the period of the sine of 6 theta? What is the period of the sine of 6 theta?
Is it
Over 3?
pi over 3?
Yeah. So won't this become 0, because nobody writes 0? Isn't this going to be pi upon 3k? Did I get that right? Yeah, okay. If I went to this one, isn't this one just going to get me negative theta equals 0, which means theta equals 0, and I get this one again. And multiples this time are 2 pi, but this one contains all the 2 pi, so I don't need to do anything. So this one basically doesn't give me any new answers. It just gives me versions of this every third or sixth guy along.
Yeah. I guess what I don't understand is why theta is equal to pi over 6, but then in the answer you wouldn't get pi over 6.
Oh.
Maybe you would, I don't know.
Oh, maybe you would. If I put this one in, won't you get pi upon 6 plus pi upon 3k? Won't you get that guy? What would you do?
So is there 2 answers, or is there?
No, they're all contained inside one answer. Actually, the one that they're all contained inside is actually that one, because that one generates pi upon 6s and then it generates the next one and the next one. So that one there,
Mm-hmm.
we generate, I think, all of them. I think that one is contained inside this one, isn't it? Isn't two of these one of them? So
Mhm.
actually, I should have probably used that one and got all the answers that matter out of it.
Okay.
Okay, kind of weird one. We've got 15 minutes, guys, so keep them coming, provided, you know, it's obvious to you. So what's the next one?
Can you use the law of sines in a right triangle?
Could you use it? Is that your question?
Yeah, like,
Oh, let's show you. So I have a right angle triangle. Let's say I know that's 30 degrees and I know that's 5, right? And I want to know this guy up here, right? Can you imagine that? And your question is, could I use the law of sines? Well, I would probably use SOHCAHTOA, but the answer is yes. So let's show you. Let's call this A, let's call this B, let's call this C. So this guy here will be called, I guess, little b now. This guy's little a, and this is little c. And we're being asked in this question to find little b, right? So if you do sine a over little a equals sine b over little b equals sine c over little c, you know angle B is 90 degrees. You know angle A. You know little a, and you're trying to find B. Can you see then that you're going to use the sine rule with these two guys? So the sine of A over little a is going to be the sine of B over little b. And the sine of A is 30 degrees. And little a is 5. And the sine of B becomes the sine of 90 degrees over little b. If you do a cross multiply, B times the sine of 30 degrees is 5 times sine of 90 degrees. Oh, wait a minute, sine of 90 degrees is 1, so you're basically getting that. And so that makes B 5 divided by the sine of 30 degrees. And so I'll go 5 divided by the sine of 30 degrees. And the answer is 10. So yeah, I could use it. If I was given that question, I would probably go something like this. This side here is called the opposite. This one up here is called the adjacent. We know that the sine of 30 degrees is the opposite over the adjacent. And so the sine of 30 degrees is 5 over the adjacent. And since I'm running short of room, if you cross multiply and divide, can you trust me that you end up with that calculation, which gets you 10. So you see it works.
And SOHCAHTOA is only in right angle triangles, right?
Correct. Don't try it the other way around. That is not going to end well. SOHCAHTOA is and must only be used in a right angle triangle. I wonder why you thought of that. Was it just a thought came to your head that maybe you could use it in those questions?
I thought of the question because on the midterm, my mind blanked when I was trying to think of the law, like the SOHCAHTOA, I think. I just
Oh,
forgot
okay.
about it. And I think I tried to use the law of sines. So
Did it work?
I think so, but
Well, if you did what we just did here, it would work, right? So it's
Yeah.
not like it won't work as long as you do it properly. It'll work.
yeah, I think it worked, but I couldn't remember, so I figured I'd check.
I don't think this is true, but I wonder if they got SOHCAHTOA by using the sine rule and just adapting it with the right angle. Because if you rearrange them, you probably could, couldn't you? You probably could find sine, cosine in particular. You can find the sine, but once you know the sine, you can figure out cosine and the other ones. I wonder if that had anything to do with where that came from. I don't know. I'm just wondering. Okay, what's our next question?
I mean, I have another one if nobody else has one. but-
Go for it. I'm sure other people like to hear
Okay,
answers.
so it's using the half angle formula, and
Okay, which one? Or is it just a general question?
it's just a general question.
Okay.
It's the cosine of negative 337.5, and they want us to find the exact value using a half angle formula.
Okay, so it was a cosine
Yes,
of negative, which is a bit unusual. Of what angle?
337.5.
Well, the first thing I would do is, if you imagine what that angle would look like, it'd actually be over here and you'd go backwards. So, right, that's what an angle of negative 337.5 degrees works with. So I would start by making that angle positive, right, somewhere, and it's pretty obvious from the visuals that it's going to be in the first quadrant. Would you agree if you just add 360 degrees to something, you can get an equivalent angle? So I'm going to do that, fella, and if we do a 360 and then a 337.5, that question becomes a much more doable question, which is the cosine of 22.5 degrees. Would you agree it's just easy to work with? So that would be my first fix. Just get an angle that I can live with. Now, isn't that going to be the cosine of a half of 45 degrees? So that's essentially going to be the theta, right? 45 is going to be the theta in the half angle formula, right? Now, when you look up the half angle formula, isn't there a plus and a minus going on and then a big square root? Have you got that guy handy for the cosine?
Yeah, it's the square root of 1 plus cosine x over 2.
Okay, in this case, I'm calling it theta, but any letter of the alphabet will do. Now, let's deal with the plus or minus. That's actually not that hard. Would you agree that guy's in the first quadrant, and so it's a plus, because cosine's a plus. So that was easy. It's not too bad. If you use this number, couldn't you it'd be quite hard to figure out where it was, right? It just wouldn't work well. So it's going to be the 1 plus the cosine of 45 degrees over 2, because theta is 45. So that's going to be 1 plus the square root of 2 over 2, all divided by 2. What I tend to do in these questions is just call it a half and a quarter. And that's the answer I would use. Was it the negative 335 that was kind of making you second guess yourself?
Yeah, so I thought that's what it was, but I think I just took the wrong number off the unit circle, just looked at it and didn't get
Oh.
one. But
So you'd actually cured that problem, but something later on came.
yeah,
Okay. We comfortable with the answer now? Okay. Okay. Looking for some more questions. If we don't have any, I can tell you some jokes before we finish. So you might want to give a question to stop that from happening.
I have another question.
I knew that would get a question out of you.
It's question 6 from test 2.
Okay. Give me a moment, I'll go hunting for that fella. There we go. And just make sure, is it this one? The sine is 60 degrees squared plus the cosine of 60 degrees squared. Is it that one?
Yeah.
Okay. If you go to your unit circle, there are two ways to do this, but I'm going to do it just using unit circle first. The sine of 60 degrees is the y coordinate. So it's root 3 upon 2, and then you square it. The cosine is 1/2, and then you square it. If you want to square a fraction, you can square the top, which is 3, and the bottom, which is 2 squared. You can square the top, which is 1, and the bottom, which is 2 squared, and you add them together, and you get 1. Or you could have said, isn't this sine squared x plus the same angle, but with cos squared x? And isn't that always 1? So couldn't I just realize it doesn't really matter what the angle is, won't you always get the answer 1? In this case, couldn't I use the unit circle? But couldn't I do this one for you? You can't do 33 degrees. It's not in the unit circle, right? You can't do an exact value. I guess you could put in a decimal value and see how lucky you get. But isn't that just cos squared plus sine squared? Isn't that guaranteed to be 1? Well, let's see how good the calculator is. In brackets, the sine of 33 squared. Oops, that wasn't squared. In brackets, the sine 33 squared plus cosine 33 squared. And the answer is 1.
So this question, if it's in the final, would it be a multiple choice or would it
Oh,
be-
this one would have to be multiple choice. It's
Okay.
so quick and so easy.
I was just wondering if it was in the written, how we would prove it if we just did the sine x and cosine x.
I mean, if it just said sine x plus cos squared x, you wouldn't really prove it. It's one of those identities that you are told is true and you just remember them.